Using the power of the James Webb Space Telescope, astronomers have stumbled upon a colossal, hyper-dense monster lurking in the deep cosmos. This galaxy cluster is so extraordinarily evolved that it threatens to completely rewrite everything we know about the history of the universe. Because according to our current models, a structure like this simply shouldn't exist. For decades, the standard model of cosmology painted a neat, orderly picture. The universe built itself slowly. Gravity was viewed as a slow, patient architect, needing billions of years to gradually pull raw primordial gas and cosmic dust together into superstructures. The absolute titans of the cosmos are galaxy clusters, gargantuan megacities that bind thousands of galaxies together through sheer gravity. Assembling one of these cosmic giants was thought to take vast eons. Yet, when JWST peered into the deep past, it captured a fully assembled, hyper-dense galaxy cluster that closely resembles the mature cosmic structures sitting near our own galactic backyard. At a recent meeting of the American Astronomical Society, researchers dropped a bombshell. Fresh observations from JWST locked onto a massive cosmic heavyweight named XLSSC 122. Sitting a staggering 10.44 billion light-years away, we are witnessing this cluster precisely as it appeared a mere 3.3 billion years after the Big Bang. In classical cosmology, this era was supposed to be the universe's chaotic infancy, a primitive time when galaxies were barely beginning to merge. Instead, XLSSC 122 is already ancient, insanely heavy, and shockingly mature. In fact, it is so ridiculously concentrated that its immense gravity physically distorts the fabric of space-time itself. It now holds the record as the most distant galaxy cluster ever observed warping light on such a grand scale. By measuring the exact degree of that light bending, astrophysicists were able to weigh its massive dark matter core. And the result poses a huge crisis for standard cosmology. A dark matter halo, this massive, tightly packed, and structurally refined, is virtually impossible so early in cosmic history. It is simply too big, too soon. This leaves us facing an unsettling reality. Our fundamental timeline for how mass assembled across time is missing a massive piece of the puzzle. And if a hyper-evolved monster is already breaking all the rules at cosmic noon, what happens when we look even deeper into the abyss? What happens when we push JWST past this impossible cluster, beyond the dawn of light, directly to the raw edge of time itself? Prepare yourselves, because you are looking at the single most distant object human eyes have ever witnessed. Scientists have dubbed it the Mother of Miracles, or MOMZ14, because to the team that uncovered it, its mere existence feels like nothing short of a cosmic miracle. For 13.5 billion long years, photons emitted by this object raced across the void. As they traversed the expanding fabric of spacetime, their light was stretched, reddened, and aged until those tiny packets of energy finally struck the golden beryllium mirrors of the James Webb Space Telescope. And what they reveal could break our understanding of cosmology forever. MOMZ14 presents a terrifying dilemma for astrophysicists. Light travels at approximately 186,000 miles per second, the absolute speed limit of physical reality. Yet, the cosmos is so overwhelmingly vast that even at this blinding speed, light takes an immense amount of time to travel across space. Given that our universe is roughly 13.8 billion years old, the first few 100 million years were shrouded in complete darkness, an era known as the Cosmic Dark Ages, where no stars or galaxies existed, only a dense primordial broth of hydrogen and helium. Slowly, gravity collapsed these gas clouds, igniting the very first generation of stars. Their fiery ultraviolet light tore through the surrounding fog in a cosmic event called reionization, rendering the universe transparent for the first time. This era, the Cosmic Dawn, is the ultimate target for modern astronomy. Until recently, the record for the most distant galaxy belonged to an object named JADES-GS-Z14-0, observed at a redshift of Z equals 14.8, showing us a galaxy as it stood just 290 million years after the Big Bang. That discovery was already staggering. But then researchers at MIT's Kavli Institute re-examined existing JWST infrared data and spotted a faint, suspicious target, an object glowing brightly in infrared wavelengths, while vanishing completely at shorter light bands. In April 2025, they pointed JWST's high-precision NIR spectrograph directly at the target to dissect its light into component wavelengths. The data confirmed a redshift of Z equals 14.44. They named it MOMZ14, and in an instant, it shattered the record to become the most distant galaxy ever confirmed. We are looking at a system whose light began its journey just 280 million years after the Big Bang, when the universe was barely 2% of its current age. To put that into perspective, if the entire 13.8 billion year story of the cosmos were compressed into a single calendar year, the Big Bang happens on January 1st. MOMZ14 appears on January 7th. The dinosaurs don't arrive until December 25th, and human history occupies only the final 10 minutes of New Year's Eve. And yet, here we are, having built a telescope capable of seeing all the way back to the morning of January 7th. MOMZ14 is surprisingly compact, spanning only 240 light-years across, making it roughly 400 times smaller than our 100,000 light-year-wide Milky Way. Yet despite its tiny footprint, it burns with extreme luminosity, shining far brighter than any current theoretical model predicts for an early galaxy. Even stranger is its chemical composition. When researchers analyzed its spectral fingerprints, they uncovered an unexpectedly high ratio of nitrogen to carbon. This peculiar chemical signature is eerily similar to what we observe in ancient globular clusters, dense swarms of old stars within our own galaxy. We long assumed globular clusters took billions of years to form, but if MOMZ14 already possesses these heavy chemical signatures just 280 million years after the Big Bang, globular cluster formation must have kicked off almost immediately after the universe became transparent. MOMZ14 isn't just an outlier, it is part of a growing, disturbing pattern. Since 2022, JWST has uncovered galaxy after galaxy in the early cosmos that is impossibly bright, wildly massive, and far too chemically mature for its age. Our leading cosmological models, built on decades of observational physics and supercomputer simulations, keep getting blindsided. This doesn't mean science has failed, it means our understanding is undergoing a fundamental revolution. So how do these fully formed giant structures exist so early in time? While astrophysicists are scrambling for answers, several mind-bending theories have emerged. One intriguing piece of the puzzle comes from recent observations revealing that a surprising majority of galaxies across large distances appear to be spinning in the exact same direction. By tracking the curvature of spiral arms and Doppler shifts, astronomers detected a clear preference in galactic spin. In a completely uniform, randomized universe, galactic rotation should be evenly split 50-50 between clockwise and counterclockwise. Finding a dominant spin direction directly challenges standard cosmological assumptions. And some scientists argue it hints at a breathtaking possibility. Our entire universe might exist inside a giant black hole. To grasp this concept, we have to look closely at black hole physics. When a massive star collapses under its own gravity, it creates an event horizon, an inescapable barrier beyond which nothing, not even light, can break free. Whatever falls past this boundary is forever severed from the outside world. But what lies inside the center of an event horizon remains one of physics' greatest enigmas. This is where black hole cosmology, or Schwarzschild cosmology, enters the picture. It proposes that our observable universe is actually the interior of a massive black hole embedded within an even larger parent universe. Consider the Big Bang. Standard theory claims the universe expanded from an infinitely dense point called a singularity. But inside a black hole, matter also collapses toward a central point of extreme density. If our universe is the interior of a black hole born in a higher dimensional parent cosmos, then the Big Bang was never an explosion of matter into empty space. Instead, it was the exact moment matter collapsed into a black hole, spawning a brand new expanding universe inside its event horizon. If true, every single black hole in our own universe could be a doorway to a brand new baby universe. This could even explain why the fundamental constants of physics seem so perfectly tuned for structure and life. Black holes that create stable, expanding interior universes would naturally reproduce more frequently across a cosmic multiverse. Furthermore, scientists suggest this model solves major paradoxes by accounting for space-time torsion. In extended frameworks of general relativity, such as Einstein-Cartan theory, space-time possesses an intrinsic twisting force caused by particle spin. At extreme densities, this quantum torque creates a powerful repulsive force that prevents matter from collapsing into an infinitely small singularity. Instead of crushing into nothingness, the collapsing core experiences a dramatic big bounce, violently expanding outward to form a new interior universe. This explosive recoil after a big bounce could be the real origin of cosmic inflation, the event we call the Big Bang. Rather than expanding from absolute nothingness, our universe may have been reborn from the core of a collapsing black hole in a parent realm, making universe creation an endless, self-replicating cycle. This could also explain why large-scale surveys suggest the universe has a preferred axis or alignment, an anomaly known as cosmic anisotropy that violates the long-held cosmological principle. If our universe inherited the spin of its parent black hole, that intrinsic rotation would imprint a preferred direction across the cosmos. Of course, there could also be a far more grounded explanation. It's entirely possible that certain key baseline assumptions, such as our calculations for the rotational speed of the Milky Way, are slightly off, distorting our reading of distant galaxy spins. Regardless of which theory proves correct, one thing is beyond doubt. The universe is proving to be far stranger, far more complex, and infinitely more surprising than we ever imagined. What are your thoughts on this? Could our universe really be living inside a black hole, or are our galaxy models just fundamentally flawed? Drop your thoughts in the comments below. And if you enjoyed this cosmic breakdown, don't forget to hit that subscribe button, because this is your ultimate home for all things space and science.